Welcome everyone, and thank you for joining us. So I'm excited to talk today about a new product offering that we have here at eFabless as part of our bigger chipIgnite lineup. And it's called chipIgnite Mini, which is a new custom chip prototyping platform for big ideas on a mini budget. So for those who don't know, I'll just give a quick overview of what our chipIgnite service is that we have been offering now for many years. It allows you to bring or create your design on your terms, whether it is a private chip design or an open source project. It might be a commercial project that you're planning, or it might be a production run that you are planning on doing on high volume. Whatever the case and whatever your background, chipIgnite is a service and a platform that enables customers for rapid IC design and prototyping, allowing anyone to create a chip, whether for research, commercial, educational purposes, or whatever you have in mind. It is a unique offering that enables you to leverage a full open source design flow and tool chain along with existing open source designs, and even enables you to integrate ready-made IP blocks so that you can take the benefit of existing work and add it to a new idea that you're looking to create. We provide onboarding for any skill level with friendly support, and it is important to us that you have the opportunity to be engaged with our staff, both to learn the process, learn how to get through to tape out quickly, and get everything that you need to get started. But we're also backed by a thriving and vibrant community that includes a lot of people from many different backgrounds, some of which have been part of the journey for only a short amount of time, others for a very long period of time, and others who come from an expansive background of chip design experience. So you can tap into that as well at any time. Plus, we offer our fabrication services and our overall platform at an unmatched price point. For a start, you can get into it at no cost at all, and to actually get a chip manufactured is at a level that has previously been unattainable. So we're quite proud of the fact that we can deliver custom silicon for your needs more affordably and more quickly than has ever been possible before. The way that we enable this to work is through a design platform and a reference design called Caravel, which is an SoC or system on chip that allows you to focus on your IP and your design scope. So the Caravel harness or frame is a connection to the outside world, but it's also an embedded microcontroller that enables you to build your design and embed it into the benefits of what our platform already offers. By merging your design with our Caravel framework, you have the benefits of a controller to drive things, but also to be used for debugging and bring up purposes. And it can even be used just as an entire standalone product if you prefer. You go through our submission process on our servers after completing your design. We integrate it all and send it off for fabrication, delivering back to you a collection of ready packaged chips, assembled daughter cards, and a plug-and-play development board. This enables you also to have an option for a pathway to production if that is of interest, whether you are looking at thousands of units or even millions of units. So chipIgnite and Caravel together make the design, development, testing, and actual fabrication project so easy. We have this full chip carrier reference design, which includes a RISC-V CPU, but a host of other peripherals as well. We have an automated project design flow, which means that it can take you through most of the steps from coding to complete silicon in an almost entirely automated fashion. But you also have the option of digging deeper and customizing things to suit your needs. And given that it's an open source tool flow, it means that you have a wide range of different possibilities available to you. We also provide a marketplace with a growing number of free and commercial reference designs and IP blocks, which enables you to assemble a design more quickly, whether it is a proof of concept or whether it's something you want to take directly to production. No need to reinvent the wheel, but we also have the benefit of a large number of open source designs that have already been made available through the past years of people doing submissions in our platform. We offer probably the most important aspect, the silicon fabrication and packaging services, which has been difficult to get access to in the past, requiring either an NDA or a very large price tag, or in most cases both. We lower that barrier better than anyone else has been able to do in the past. And at the end, as we said, you have the evaluation boards, the chips, but also a software testing framework that enables you to get through getting your chip operational and into a product more easily. You can run things directly from our board. You can plug your board into a PC, and then you can use our software testing framework to see what's going on and take control. Now, if that wasn't already enough, by popular demand, we have this new small but powerful template that we can offer for the toughest of tight budgets. And this enables us to unlock the chipIgnite Advantage now for just $3,500 per project using chipIgnite Mini. So, chipIgnite Mini, which is based on Caravel Mini, and enables you to unlock the full potential of our service for small design prototyping. So what we do with chipIgnite Mini is we take the existing Caravel framework, some of you might already be familiar with it, and divide it across 4 independent customer projects. And what that means is that each customer of chipIgnite Mini will receive a dev kit and 25 QFN packaged chips, all for $3,500. And this enables you to use the capabilities of the fully fledged Caravel chip, with each design included on the chip using a dedicated space and access to a wide variety of different connections. We take care of the process for you of integrating your project into this harness. So you don't need to be concerned with the fact that there are multiple projects involved. Each project independently shares the same chip without being able to see or access each other. Caravel Mini does this by being hard configured within the package for each customer. So we take care of the integration, you focus on your design and enjoy high performance with easy integration and 2 millimeters squared of die area, which may sound small, but is enough for on the order of 150,000 to 200,000 gates. So this extends our existing range of offerings from the original Caravel, which is probably our most popular for both digital and mixed signal production and prototyping designs, as well as Caravan for more specialized analog prototyping, and OpenFrame with a larger area for more advanced projects, to now include this 4th option with 36 programmable IOs, the full Caravel system on chip, SoC, and 2 millimeters squared of design space, focused on digital prototyping at this stage. And talk a little bit about what is included in the Caravel Mini SoC platform. So system on chip means potentially quite a lot of different things. And in our case, it's a wide variety of different functionality, which comes together and enables you to decide, do you focus on your design implementing your core functionality, or do you offload some of that onto the processor and the peripherals that it provides? So Caravel includes a RISC-V processor, which has its own integrated SPI flash controller, meaning that it automatically will read firmware code from an external flash ROM. It includes a small amount of local memory, which is for general processing and instruction cache. It provides a number of serial interfaces, such as a basic UART and a serial peripheral interface controller of its own that you can leverage. And as we said, 36 general purpose input-output pins. It provides a clocking circuit that can generate 2 different clock sources with multipliers and dividers, what would typically be called a PLL, but in the case of our system, it's what's known as a DLL. And that can give you the capability to have an independent clock source driving the processor and another separate clock source driving your design, if you so prefer. We also provide a power on reset circuit and a counter timer that you can use. Caravel Mini also allows your design to communicate and be controlled by Caravel Mini with 32 logic analyzer pins, which can be used bidirectionally, a 32-bit wishbone bus for interconnection between different devices that you have on chip and with the Caravel SoC itself, and 6 user interrupts, 3 of which are directly wired to your design and available to you if you choose to use them, and 3 more that are available externally. And 1 digital power domain means that it's dedicated to your design, while the other designs sharing the chip are not powered. Okay, so moving on, let's just have a quick look at how you might get started with this right now. And bear in mind again that this is at no cost to learn how to create a design and actually get it through to a stage that you could have it fabricated. We have a repository set up, and we'll provide this slide deck at the end along with some other web addresses. But we use the platform GitHub to share our repositories presently. GitHub is free to sign up for if you haven't used it before. And this particular repository, called Caravel User Mini, is a reference design, very similar to our Caravel User project, for those who might already know about it. It has everything in there that's required to be able to build an example design that you could tape out. So you would use the create new repository link from there, create a copy of this repository for yourself and give it whichever name you like. You then choose, do you want it to be publicly accessible? You may want it to be an open source project, or do you want to make it private? Now, probably most of our customers will use the private option. Once you've created the repository, it then has a copy of all of our standard files, and you can then get a copy of it on your own machine. So to do that, you would typically run the command git clone and then whatever the web address is that GitHub gives you. And if you need any assistance at all with GitHub or Git and Git clones and how they work, reach out to us, because it's quite straightforward and we'd be happy to help. Once you've got a copy of the repository, run the command make setup. And note that this is focused on a Linux environment at the moment, but you can definitely also use it under Windows and macOS. Ask us if you need more information. The make setup command will take approximately 10 minutes, and we recommend having at least 12 gigabytes of disk space free, as it will go and download a number of packages and do some installation, but also you should allow enough space so that you can actually run through the process of building the final layout. What this gives you is a collection of different files which are common to most of the eFabless and chipIgnite projects, including the Caravel core itself, the OpenLane toolchain, which is what actually does the conversion from code into silicon layout, and the PDK, which is necessary for the system to know how to prepare it for the foundry to do fabrication. But the new inclusion is the Caravel Mini subdirectory as well, which includes all of the files that make this 4-panel layout work. So the Caravel Mini project that you would clone from our example does include an example trivial counter design, so that you can get a sense of how these different things work and use it even as a reference that you might want to extend yourself or replace it with your own design. The example project includes a 30-bit counter, which by default is in a free running mode. So from power up, it will count with each incoming clock pulse. But through the Caravel RISC-V CPU, you can take it over and you can use wishbone writes to set a specific counter value, or you can use the internal logic analyzer pins to take control in other ways, and for example, override values or change the way that it counts. The essential structure of the Caravel Mini example project is that it has certain input files. So for example, we have Verilog source code, which includes our main counter designed example. A wrapper file, which is what provides the standard interface between your project and our harness. So you basically do simple wiring between your design and the rest of the chip through that file. We have a DV, or design verification subdirectory, which includes some tests and simulation scripts so that you can actually verify your design before it gets submitted. And these are implemented in CocoaTB, which is a Python-based framework for developing digital design verification test benches. There's also an include subdirectory, which has some basic files for linking all of these things together. And then we have the configuration for OpenLane, OpenLane being the tool that does the synthesis or the hardening, which is the conversion from code to actual silicon layout. So we provide a standard config file in JSON format. It's relatively straightforward to read. Most of the information in there you don't need to worry about touching. You might specify, for instance, what your preferred clock speed is and what your project files are that it needs to consider, but most of the rest of it you can leave as is. There is also an SDC file, which again, you don't really need to worry about too much for most cases, but it contains timing parameters that allow the tools to verify that the design can be laid out in such a way that will meet your expectations. And we provide the standard one to cover most cases already, so you don't need to worry about changing it. When you actually go through the process of running OpenLane and doing the hardening, the results are that it will produce a GDS file. For those familiar with PCB design, this is like the Gerber of a silicon chip, and it contains all of the layouts for all of the silicon and metal stack up. And this is what actually gets considered by our servers for fabrication of chips. But it also produces a runs folder, which includes a lot of data and other reports. So if you want to do a deeper analysis of the results, you can. If you have any problems, you can use that to diagnose the source of those problems. So if we have a quick look at what the hardening process is like, I already mentioned that there are these essential RTL files, which are probably the ones of most interest to anyone starting out a design. And we've got the example here of the wrapper, where the part highlighted here, this module, is the connections that we provide as standard. These don't change, and they include the wishbone bus, which you may choose to just ignore completely, depending on your design requirements or your level of experience, but it is there in full if you want to use it. We have the logic analyzer signals and the actual real-world connections, the GPIO inputs and output connections. And we have an optional second clock and the optional user interrupts as well. And then below that, we have the basic instantiation of your module. So your own design gets plugged in here and you can wire it up as you require. And for those otherwise already familiar with Caravel, note that you can include logic for synthesis in this Caravel mini wrapper, whereas you cannot in the standard Caravel wrapper. It has to otherwise all be included in your own module. So even without looking at these files or modifying them, you can then run the command make user project wrapper mini 4. And it will go through a process that takes about 10 minutes of running the OpenLane flow, where it'll go through synthesis and timing analysis and build the final layout for you. You may get some warnings, which typically you can ignore, but by all means, reach out to our helpful team and ask us if you need any help. But finally, what we're looking for is the success message, flow complete. And if you have any trouble getting to that stage with your own design, then again, let us know. So what this finally builds is a layout that will go into silicon, and we can see here that this example counter uses almost none of the available space, so you've got plenty to fill. At a deep level, we've got the actual circuits that are made up, and this is handled for you automatically using the Skywater standard cells. And these are all laid out as efficiently as the tool is able to determine for you and for the best timing. For more complex designs, obviously, you'll fill more of the area, it'll take longer, but we have ways that we can help you accelerate that also. And all of that space that gets laid out then gets included as one of the 4 panels in the main wrapper that we integrate into the final chip. So to just take a quick look at the comparison of chipIgnite with the chipIgnite Mini offering, both have the full Caravel SoC and both have full digital support through OpenLane. The analog and custom layout support is currently not provided for chipIgnite Mini, which as a result means that use of IP blocks is limited to soft IPs, which basically means they are implemented as Verilog code rather than pre-created layouts. There are actually ways around this if you want to use macros, for those familiar with macros. So again, reach out to us if you would like any help. In terms of capabilities, chipIgnite does offer some extra I/O pins over chipIgnite Mini, but with 36 bidirectionally capable GPIOs, you've still got a lot of flexibility available. Both offerings provide the full 32-bit wishbone bus, which is a fantastic feature for being able to connect together multiple designs and multiple IP blocks. We provide a quarter of the logic analyzer pins in chipIgnite Mini, but 32 is still quite a lot and quite flexible given that they are bidirectional. At a more physical level, there are only 4 metal layers as opposed to 5 with a full chipIgnite, but you don't need to worry typically about what this means because the tools handle all of the routing for you. It may just mean that in some cases it has higher density on lower layers, but that's usually automatically handled. Power distribution is more flexible with chipIgnite. chipIgnite Mini provides just the one digital power domain. And chipIgnite Mini provides a smaller area, but as we've said, there's already quite a lot you can do within that space. And in terms of what you actually receive, you receive 100 parts, whether they are QFN or bare dice with chipIgnite, and 25 QFN packages specifically with chipIgnite Mini. 2 of which will be mounted on daughter cards, which can then be plugged into the evaluation board that we provide. Just keep in mind that some of these things are potentially going to be extended further in future generations of Caravel, both Caravel Mini and chipIgnite Mini. So stay tuned, but it's definitely ready for digital design purposes right now. And just also keep in mind that the submission deadline for chipIgnite Mini is 1 week earlier than the deadlines otherwise given for chipIgnite. And we do have our next one coming up in September, which means that you would need to have your design ready by September 9th. If that's too early and you're still interested, then we also have a November shuttle, and then for next year, April and June as well. And finally, you can go and buy chipIgnite Mini right now, if you like, from the eFabless store. Go to store.efabless.com and you will find the product available there for $3,500 US. And buying one of the instances of this then unlocks the full capabilities as well, not only of the standard offerings in our eFabless marketplace, but also the interaction that you can have with our expert team, including a chipIgnite project assessment, which is a great way at the early stages to help you stay on track and do a feasibility study of your design, and also just get expert advice from us on great ways to get a successful outcome more quickly. We also provide chipIgnite design reviews, which you would typically do towards the end of your project prior to submission. But we encourage you to talk to us and reach out for support if you have an existing reservation, because it's important to us that our customers have a successful tape out, and this is something we really like to help you with. As I said, we have some links and we'll provide this slide deck, so I won't go into those too much at the moment, because now it's time for any outstanding Q&A. So let's just have a quick look now. We've had quite a lot of questions and several of them have gone through the chat. So Andrea and David, are there any other outstanding questions at the moment you'd like me to answer live?
There are a few under the Q&A function, and if you can just remind everybody to submit their questions using Q&A and not chat.
Certainly. So in Zoom, there is an option to go to questions and answers as opposed to the webinar chat. So if I just have a quick look now, what have we got? Are bare dice available? Okay, so if you use the full chipIgnite service, then you can choose whether or not you go for QFN packaged parts or bare dice. There is also the option for a mix where you can go for 100 QFNs plus 25 bare dice, but there is an extra price associated with that. chipIgnite Mini, however, does not offer bare dice at this time. Are there any successful tape outs for out-of-order multi-cores with DDR memory? If yes, how much of the 10 square millimeters did it take? There are some projects that have attempted this, and you could probably look at our existing project pages online for some of the open source shuttles that have run in previously. But there's potentially a lot of different complexity involved in that. We might need to take that offline if you'd like to discuss it further. Does the GitHub tool include memristors? Well, there is the option for ReRAM with chipIgnite, but not with chipIgnite Mini at this time. ask us if you'd like more information. ReRAM shuttles are run 2 times per year as opposed to 4 times per year. And we have had a number of customers tape out with ReRAM before. What's the best way of networking IP or memory interfaces? I can't find IP blocks in the design catalog. Should this be an external chip? No, there are. It depends whether or not you mean the interconnecting of IP blocks and memory, in which case Wishbone is probably the most common interface, though there are others. And all of the available marketplace IP that we currently have offer some form of interconnect bus, and many of them offer Wishbone or are soon to offer Wishbone. As far as IP specifically for networking, there are not any that are specifically available for things like Ethernet or Wi-Fi at this time, but this may be something that is offered in future. Again, maybe reach out to us separately if you'd like more information. Okay, and what is the yield for each package? You would probably need to talk to us about your specific requirements, because yield figures can vary, but this is a very mature process, and we can provide some more information offline. Do we provide e-certificates to participants? Typically not, though. If you specify more about what you're looking for, then we may be able to accommodate your needs. And is there DRAM on the dev board? There isn't typically a need for it. The dev board, the evaluation board, includes a flash ROM so that firmware can already be uploaded and tested, which can be done conveniently through your PC. But other than that, it's not typically a requirement, though you could interface DRAM yourself if you needed it. Okay, and I think they're probably the main ones. We're coming up to the half hour now that we were intending for this webinar. So I think that's probably enough for now. Oh, just one last question. Someone is asking about our SRAM macros. We do offer commercial grade SRAM macros. They can be used with chipIgnite Mini, but that's a case where probably you might want to talk to us about specific details of how to interface that. Okay, all right. So that's probably everything that we can go through today. So thank you everyone for your time. And we look forward to seeing you in an upcoming webinar. We are planning more on other design integrations and practical projects that you can do both with chipIgnite and chipIgnite Mini. So stay tuned, and we'd love to see you there also. Thank you.